Hello, my name is Adrian Stevens. In this video we're going to look at noise reduction in Audacity for Librivox recordings. In a previous recording I've shown noise reduction on microphones. In this video we'll go into a bit more detail. We'll look at noise reduction of a good clean recording, and we'll look at noise reduction of a noisy microphone. We'll also hear the effect of excessive noise reduction or attempted noise reduction when really the recorded signal was too poor to expect to be recovered cleanly from using noise reduction. Okay, so let's record a test sample using the Yeti microphone, which is a high quality USB condenser microphone. Let me set the level. Test, test, test. It's between 6 and 12 at the peak, which is about where it should be. Testing, testing. 1, 2, 3, 4. Now is the time for all good people to come to the aid of the party. Okay, so we've done a recording on this microphone. I'll change the display mode to waveform dB, and this enables us to see the noise more clearly. I recorded a silent period at the end so that we can listen to the noise, and also for use with noise reduction. What I'm going to do is to normalize that portion so that we can hear what is in the noise. Well, what I heard there was, rather unsurprisingly, the neighbour is mowing their grass, and there's a collared dove in the trees above, which is doing what collared doves do. So, there is a certain amount of noise. Let's listen to the speech with the noise and see whether it's obvious or not. Testing, testing. 1, 2, 3, 4. Now is the time for all good people to come to the aid of the party. Well, I couldn't hear it on the headphones, but then I've still got that environmental noise, so I'm unlikely to be able to hear it. By eye, anything at the minus 50 dBs level is probably acceptable as a recording. So as it stands, we could probably submit this to Librivox and it wouldn't be rejected on the basis of background noise. Let's look at some Audacity tools for evaluating this. So one thing we can do is we can mark a section of speech, analyze contrast. So we're going to contrast two regions. We hit the measure selection, then we mark another section and hit measure selection, and it tells us that the difference between these two is 32 dBs, and it says WCAG 2 pass. This is related to an internet standard for the quality of audio put on websites. Okay, so it's 32 dBs. We could also export this to Audacity and check it with the checker program. I have another video that shows the installation of the checker plugin. So I'm going to save this using the standard settings, 128 kilobits per second mono, constant bit rate. I put that on my desktop. Let's run the checker program. And drag the file into checker. Well, it doesn't like the fact that it's got spaces and no underscores. it did actually complain about the background noise. It said it's 47.1 dBs. Okay, so perhaps we need to do something about the background noise, and I would do it anyway as a matter of course. There's a number of things we could attempt. If we knew that the noise was in a particular frequency band outside of speech, we could create a filter to get rid of that noise. So one of the things we can do is analyze plot spectrum. And we can see there's a strong peak around 100 Hertz. So, and the mower stopped now, so I could do a cleaner recording. Actually, let's do that. I'll do a cleaner recording and we can compare the two. Testing, testing, 1, 2, 3, 4. Change this to waveform dB. Wow, look at the difference between those two. Let's normalize. And listen to this. So I could hear rumbling going on in the background. That's probably traffic in the roads around me. And we could use the analyze plot spectrum. And we see a completely different spectrum to the one we saw previously. Let me make a copy of this so that we can compare them. Okay, we'll bring that back in a minute, and let's go back to this track and plot the spectrum of this. I used the Windows snipping tool to grab that window. So this is the noise, and it's dominated by really low frequencies, rumbling. That's the traffic. And there were some birds squawking in the trees. But this is a completely different shape, and it's dominated by something at around 100 Hertz-ish. And that was the mower outside, which has now stopped. So if I was to save, I've got to hit the Control Z to undo that. If I was to save this and check it with a checker, I reckon it will say it's okay. So let's export this as MP3. Let's call it mic test 2. Can't spell, not that that matters. I'll save that and run the checker program with that file. So it complains about the underscore and spacing, but it doesn't complain about the background noise. And so this is now an acceptable file, and we can see the difference is about 16 dBs. Well, let's assume that we didn't have control of the environment. We couldn't wait for them to stop mowing, so we need to clean this file in order to reduce the amount of background noise. So what we do is we select the region to be, we select a region that is quiet. So when you record, you should always follow it with, a few seconds of quietness, just so that you can do the noise reduction. So Effect, Noise Reduction, get Noise Profile, select the entire track, Effect, Noise Reduction. Now we have a number of parameters to play with here. The last two boxes generally set to 6 and 6. I don't really know what they do. I've not experimented with them very much. But this is following the recommendation in the Librivox documentation. This one I do know what it does, and it's basically how aggressive the noise reduction is going to be. This is trying to reduce the noise by 12 dBs, and if you remember, the noise between the two, these two, is roughly 16 dBs according to the checker measurements. So let's say make it 16 dBs. And it seems to have done a good job of reducing stuff over here. Let's listen to what it sounds like. Testing, testing. 1, 2, 3, 4. Now is the time for all good people to come to the age of the party. And that sounded perfectly fine to me. There are some of these spikes here. These were probably clicks or whatever in the environment. And also you see there's a spike here. I could just clear those with Control L if I wanted silence at the end of the recording. You're supposed to leave a 5-second silence at the end of recordings, so you could clear that, or you could delete it all and insert 5 seconds of silence. It doesn't matter. But the point is that this visually has done a good job on reducing the noise in the quiet bit, so we assume that it's also done a good job of taking the noise out of the spoken part. And listening to it, I certainly couldn't hear the noise. Let me undo that. No, let me export that, and we'll check it with the checker program. And it's complaining about the file name, and its measured background noise of 33.9 dB is pretty similar to the cleaner recording I did, the second recording. Okay, so we've shown doing noise reduction on a good microphone. Let's now do a more challenging noise reduction. I've got a USB lavalier that I've shown in some other videos, which I'm going to plug in, and I'm going to clip it to the stand of the microphone. So it's now 18 inches away from my face. So this is not where you should put a lavalier. I'm ensuring that it's going to get a low level of sound from my voice. And we already know from looking at in previous videos that there's a high level of noise, electrical noise in this microphone. Let's see what happens. I'll bring Audacity back. Let's mute this and put it out of the way. Okay. Oh yes, we've got to rescan audio devices, so because I've just plugged it in. And now I look for the microphone. I'm going to set the recording level up to max. And if I monitor, testing, 1, 2, 3, 4, we see my voice is somewhere around -18. So it's at least 6 or 9 dBs lower than it should be. Let's do a recording. Testing, 1, 2, 3, 4. Change to waveform display mode, and we can see that we've got the speech is low and the noise is quite high, but it's going to get even higher because now I'm going to normalize it. In fact, I'm going to apply the replay gain plugin. Again, this is subject of a previous video in this series. So this has set this now so that the speech is acceptable, the volume is acceptable to Librivox. Let's listen to it. Testing, 1, 2, 3, 4. Well, it's not very clear, and the reason it's not very clear is because the microphone is well away from me. The quality would improve hugely as you move it to your face. So, you know, that's important. Whatever you're doing, make sure that your face is close to the microphone, as mine is here. There's also an electrical noise. We could use the Audacity tools to look at that noise. So, analyze. and we're going to plot spectrum. And I've shown this microphone before, but what we've got here, I don't know if I can make this any bigger. Oh yes, I can. We've got a big spike at 1034 Hertz, it says, and similar spikes at all multiples of this. And there's spikes here. I don't know if this is due to the microphone or in the environment, but certainly this big spike here at minus 57 dBs. This spike is at minus 69 dBs, so 12 dBs less. So there's a big difference between this and this. Well, what can we do? We can use noise reduction. If there was just a single spike, we could do what's called a notch filter. So let's just play with doing a notch filter. So we're going to do Effect, Notch Filter, and we're going to put in 1034, which was the frequency of the peak, and we're going to make it fairly narrow, so say 10, a Q of 10, and click the OK button, and didn't see a huge amount happening. Let's look at the Analyze Plot Spectrum, and what you see now is the effect of the notch. This peak has reduced from about here to about here, and it says it's at 1026, so perhaps if I did another notch about there, we might get rid of this peak entirely. But let's listen to it. Well, perhaps the whining sound has reduced, but I don't think by filters, simple filters, we're going to get rid of that. So I hit Control Z to undo it. Let's see how noise reduction works. Effect, noise reduction, get noise profile, select the whole track. Effect, noise reduction, let's give it the same, 16 dBs. And you can see that it's reduced the noise. Let's see how it sounds. Testing, testing, 1, 2, 3, 4. I can still hear that whine in the background. If I was listening to a book and that had that whine in it, it would annoy me hugely. So I'm going to give it some more noise reduction. Let's double it. I'm hitting the Control R, which means repeat, and it appears visually to have got rid of all of the noise. Let's hear what it sounds like in the speech. Testing, testing, 1, 2, 3, 4. Well, now the noise has gone away and is no longer annoying, but the quality of the speech has been damaged. I would say damaged fatally by this procedure, because it now just sounds very processed. So I think the finding of this little experiment is, yes, you can reduce noise to almost nothing with the noise reduction plugin, but you might not like what it does to your speech. So let's get a good recording with this microphone, which I'm going to do very simply by moving it closer to my mouth. Let's monitor. Testing, testing. I could turn the gain down a bit now. Testing, testing. 1, 2, 3, 4. Testing, testing. Yep, that's good. So let's record. Testing, testing. 1, 2, 3, 4. I can also tell you that the lawnmower started up outside, so expect to see similar noise to the first track from the environment. And of course we've also got the electrical whine from this. So now here's what we see. Let's listen to the noise. Okay, so it's a mixture of the lawnmower outside and also the electrical whine. Let's do noise reduction on this. Effect, noise reduction, get noise profile, select the track, effect, noise reduction. Let's give it the 16 again. And we see now that a single run of the noise reduction has apparently reduced the noise level to a low level. And there's a couple of reasons there. One is I turned the gain down on the mic because I was speaking more closely to it. And the second is that we didn't have to amplify it. With the previous track I had to do replay gain, and that amplified it by a number of dBs. So the power in the noise is much less to start off with. Let's see what it's done to the speech. 1, 2, 3, 4. Well, apart from being not very bassy, that was perfectly legible, and listening to that for a while wouldn't bother me. Let's just analyse this and see if there's any trace of that 1 kHz spike. Well, 1 kHz, there's a spike at 1034 Hz, so you see the spike here, that's due to the electrical noise, but it's less than the power in the speech area, which is, you know, around here, 200 up to whatever. So this is the area where the power, where the speech is causing the power, and then up here this is the hiss, probably the electrical noise again. So in this video I've shown recording of a good microphone with some environmental noise and a successful noise reduction that removed the environmental noise. I've shown what happens when you have a clean environment, and a recording with a decent microphone and decent placement did not require noise reduction. I've shown with the lavalier microphone recording with a stupid placement produced a result that couldn't be clean because the noise level was always going to dominate the speech level. And I've shown with a good placement of the lavalier close to my mouth, even a low quality device like this can produce acceptable quality recordings. I hope you found that interesting. Goodbye.